All right, so let me draw up the lab for you so you know what to do, and then we'll see if it makes some sense. All right, so this is the force sensor. So you're going to have your car. It's going to be out here. You're going to give it a little push. It's going to come in. The car is going to come in, hit, and then go back out. Is that cool? Now, the computer is going to graph it for you. Let me show you the 3 graphs you're going to get. I don't know how they're going to be arranged on your screen, so we'll just see what happens. So you're going to get a position graph, so time and position. You're going to get a velocity time, and you're going to get a force time. Is that cool? So, and the computer's going to give you all 3, which I love. So, if you think about the position, it's the position relative to this sensor. So, here's your car. You push it, it goes away from your sensor and then comes back to your sensor. Does that make sense? So, the position graph should look something like this. It goes away from your sensor and then comes back toward it. How's that look? Is that cool? All right. What about the velocity? So you're going to give it a little bit of a push. Okay? You're going to give it a little bit of a push. It's going to move away at a constant speed. So it's moving away at a constant speed. Then it hits the thing, slows to a stop, and comes back. So while it's in contact, it's going to go like this, and then it's going to come back at a constant speed. How's that look? Is that cool? So this is what you're looking for. Now the force one is interesting because the only time it's reading any force is when the thing's in contact with it. So what does that mean? That means that the force is 0, 0, 0 until this moment right here where it pushes on it, until this moment right here. And then it's 0 again. Is that cool? So the sensor's not pushing. This is where it's pushing, and it pushes, and the force goes up, and then goes back down as it sends it on its way. This is what you're looking for. Do you think you can find it? All right. Yes?
Does the thing that it hits also have a sensor in it?
No. That would be cool if it did, but it doesn't matter because those are Newton's third law force pairs anyway. The force that the car exerts on the force sensor is the same force as the sensor exerts back on the car. So if it did, it would read the same force.
Okay.
It's cool though, Jay. That's a great question. All right, now, what do I want you guys to do with this data? It's a great question, Don. Here's the thing. I want to know today is there a relationship here between the force that you get and the speed? Like, if you pushed it harder, what's probably going to be true about the force? Do you think if you have a bigger speed, you're going to get a bigger force? I think you probably are, right? So here's what's cool about this, is if you push it faster, your initial velocity is going to be bigger, true? And then your final velocity is going to be bigger also. Does that make sense? Something else is cool that happens is if you do that, not only is your force taller, because it's more force, but it actually is probably wider also. So that's a weird thing. So we're going to have to account for all this. And let me show you what I want you to do. Okay? Let me show you what I want you to do. First of all, this value right here, that's going to be your initial velocity. Your initial velocity is the velocity right before it hits the sensor. Is that cool? This one down here, what do you think this one is? That's the final velocity. So you're going to make a data table, and in your data table, you're going to have initial velocity. Cool? Then, the next thing you're going to have in your data table is your final velocity. Sound good? All right. Now, if I have initial and final, what am I actually interested in here? What do you think I'm actually interested in here? We talked about this the other day, didn't we? What does the triangle mean? It's the change. What Greek letter is it?
Delta.
It's the delta. So how are we going to get the change in velocity?
Final minus initial.
Good. You do the final minus the initial, right?
Yeah.
Now, what we're going to look for is, I want the absolute value of that because it's going to have some absolute value of your change in the velocity. Is that cool?
Yeah.
Feel like you could do that?
Yeah.
I think you can do that. Now, the other thing, it's a little outside of any understanding you have yet, but it's close to some things we've done before. See, one of the things is that if you push it harder, give it a bigger speed, the force is going to be more, so the up and down value is going to be bigger, but it's probably going to be wider also. So to take both things into consideration, we're going to ask the computer to shade it in for us and give us the value. And the computer's going to do it automatically. We're going to call this the FT area. I will show you how to do it, but that's the thing that we're going to plot over here. So, and it's going to be negative, so it's going to be an absolute value too. And then once you get your 5 data points, so you're going to push it extra small, small, medium, large, and extra large. You're going to get 5 different delta V's. It's going to give you 5 different areas. Then you're going to plot it with the end plot and put it on your whiteboard. So your whiteboard should have like this. Okay? These 3 graphs don't need to go on your whiteboard because we're just using them to get the data. What do you think? Do you think this is something you guys can do? It's actually super fun and easy, to be honest. So go to the computers. You're going to start the Logger Pro program. Okay. When you get the Logger Pro program up, let me know. I'll come around. I want to make sure your sensors are zeroed, and we'll do a run, and you'll see. I'll teach you how to analyze, and we'll go from there. All right.